everyone, I'm Claire and I will be showing you how to solve quadratic equations by extracting square roots. Recall that a quadratic equation can be written in the general form ax squared plus bx plus c equals 0, where a, b, and c represent real numbers and a is not equal to 0. Some examples of quadratic equation are x squared minus x minus 6 equals 0. 4x squared plus 4x plus 1 equals 0, and x squared minus 16 equals 0. In this section, you will encounter 4 methods for solving quadratic equations, like factoring, extracting square roots, computing the square, quadratic formula. But we are going to focus on extracting square roots. Objectives. Use the square root property to solve equations of the form x squared equals c. And the other one, use the square root property to solve equation of the form ax plus b squared equals c. First, we're going to use the square root property to solve equations of the form x squared equals c. We will now solve x squared minus 16 equals 0 in another way. This time, we will ignore the zero factor property condition that requires 0 on one side of the equation. Instead, add 16 to both sides to isolate x squared. So, we are going to transpose negative 16 to the other side. So, it's going to be x squared equals 16. We see that x must be a number whose square is 16. Therefore, x must be a square root of 16. Since every positive number has two square roots, one positive and one negative, we have x equals square root of 16, or x equals negative square root of 16. So, to solve, x equals square root of 16 is 4, so x equals 4. And the other one, x equals negative square root of 16, so it's going to be x equals negative 4. As with the factor method, we find that the solutions of x squared minus 16 equals 0 are 4 and negative 4. This approach illustrates how the following square root property can be used to solve certain types of quadratic equations. The square root property of equations. For any non-negative real number, c, if x squared equals c, then x equals square root of c, or x equals negative square root of c, we're going to write the conclusion of the square root property in more compact form called double sign notation. X is equal to the positive or negative square root of c. In our example, to make our answer in more compact form, we are going to use the double sign notation. So x is equal to the positive or negative 4. The square root property is especially helpful in solving quadratic equations of the form x squared minus c equals 0, where c is not a perfect square. Like for example number 2, we have x squared minus 5 equals 0. Transpose negative 5 to the other side, so x squared is equal to 5. Use the square root property to isolate x. The answer would be x is equal to the square root of 5, or x is equal to the negative square root of 5. Use double sign notation, so x is equal to the positive or negative square root of 5. To check if the answer is correct, substitute square root of 5 and negative square root of 5 for x in this original equation and solve. For example number 3, we have 4x squared minus 12 equals 0. Transpose negative 12 to the other side, so we have 4x squared equals 12. To isolate x squared, divide both sides by the coefficient, which is 4. We get x squared equals 3. To isolate x, use the square root property. So, x is equal to the positive or negative square root of 3. For example number 4, we have x squared equals negative 4. Use the square root property, so we get x is equal to the positive or negative square root of negative 4. Since the square root of negative 4 is not a real number, the equation has no real number solutions. So x is equal to 2i, meaning imaginary number. We can extend the square root property to solve equations that involve the square of a binomial. Instead of a variable squared on the left side of the equation, we have a quantity squared. We still use the square root property to solve the equation. We want to eliminate the square on the binomial so that we can eventually isolate the variable on one side of the equation. For example, the square root of x minus 3 equals 36. Use the square root property so we get x minus 3 is equal to the square root of 36, or x minus 3 is equal to the negative square root of 36. Use double sign notation and then evaluate square root 36, which is 6. So x minus 3 is equal to the positive or negative 6. To isolate x transpose 3 to the other side, it is standard practice to write the number in front of the positive negative symbol. So x is equal to 3 plus or minus 6. To find the solutions, we perform the calculation using a plus symbol and then using a minus symbol. So x equals 3 plus 6, we get x equals 9. Or x equals 3 minus 6, we get x equals negative 3. To check, substitute both answers for x in the original equation and then solve. For example number 2, we have the square of 2s minus 4 equals 7. By the square root property, 2s minus 4 equals square root of 7, or 2s minus 4 equals negative square root of 7. Use double sign notation, and to isolate the variable term 2s, transpose 4 to the other side. To isolate s, divide both sides by 2. So s is equal to 4 plus or minus the square root of 7 over 2.
I hope you learned something new. Just remember that mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. Thanks for watching!